So, number 2 here. Well, actually, before I do number 2, do you need to see anything from number 1? It's okay? Yeah. Right, so number 2 then. So you have your mobile phone mast, and its range is 35 kilometers. So that means, you know, it can reach up to 35 kilometers away. Come on, guys, hurry up. You just about get in range, and you travel for 42 kilometers, and then you're out of range. And my question is, what is the shortest distance? So that's the distance here, x, let's say. And that other distance there is 42. Now, if you think about it, you have all 3 sides here, which means it's enough to know all 3 angles. Probably the most important angle you should try to find is, I'd say, this angle. So using the cosine rule, I can say, see, I want this squared equals this, okay. So cosine rule says 35 squared equals 35 squared plus 42 squared minus 35 times 42 times cos A. Now, the reason I started off like this is because I want to have this angle in my equation. Come on. So, guys, come on, focus here. I want this angle, so my cosine rule needs to look at this side squared equals this squared plus this squared minus twice this one times cos of the angle in between. So this 35 here is the side opposite the angle I want. That's how you should start. So if I want this angle, I should start with the opposite side of it. Okay? 35 squared equals 35 squared plus 42 squared minus twice 35 42 cos the angle in between. Now, on your calculator, please tell me what this comes out as, or just hand me a calculator too. Thank you. Okay. Sorry, you're right. I left out my 2 here. There's a 2 here. It is, but you see, I've said nothing about circles or theorems of circles or anything about that. So I know you're right. There's
no, even outside of the circle theory, you don't even need that. We just need Pythagoras, don't we? Yeah.
No, because no, you see, this is the thing. Now, hang on, I'll say something in a minute about that. Okay. A equals 53. Now, I'm not quite finished with that. If you use Pythagoras to get this side, right? You need to know the hypotenuse and one other side. So what's this side here?
21.
But you don't know that. No, you know the total is 42. So you're assuming that this splits it in half, which it does, but that's a circle term which I've not done with you. So if you know that from something I didn't tell you before.
But if we know that there's an angle there,
yeah.
Doesn't that simply mean that it shouldn't be obvious that is that's perpendicular to whatever you're bisecting there?
Correct. Well, what do you see? But you're using the word bisect. You look, I know what you're getting at, and yes, it does split in half. And the point I'm making is, I've not told you this, but that's a circle theorem. You know, a circle. There's a theorem for circles that says, if you have a chord, and if you draw from the center to the chord, so it's perpendicular, then it would split it into two equal parts, you know. But that's a geometry term which I've said nothing about. So I'm trying to do this only using trigonometry instead of geometry. If you used 21, you would have gotten the right answer. But I'm telling you now, you had no right to do that. Okay? Right, so I have A is 53.13. And I can finish off by saying sine A equals opposite over hypotenuse. So the x is 35 sine A. So therefore the x is 28 kilometers. Okay. This confused so many people yesterday, but once the diagram is drawn, I hope it's not as confusing. Yeah? Okay, I'll do number 3 now once you write this down. Or did you write it down? Yeah? Okay. So, next one now. Come on, Ali, hurry up. You didn't get your physics book. Oh, you got it now. Number 3. Number 3 is important because it was an exam question recently. I think it's come up twice now. So, you have a student and they want to measure the height of a tree. So height h. When they stand 5 meters away, is it? No. When she stands and looks at the tree, it makes an angle 45, and then she moves 5 meters. So this distance here is 5 meters. And then she looks up again, and the angle is now 50. Yeah, that's all you know. 50. Sorry, that looks like a 60, I know. 50. And the tree is like that. Okay. So the first thing we need to do is find all those missing angles, which I'll do in red. So this is 50, this is 90, so therefore this one has to be 40, isn't it? This is 50, this is 180, 130. This is 130, this is 45, that makes 175, so therefore this one here is 5. Now, I shall find this side here, and I think I can only use the sine rule. So I'll say sine 45 over x, sine 45 over x equals sine 5 over 5. Bit of rearranging gives me x equals 5 sine 45 sine 5. Isn't that right? X equals, yeah, over sine 5. What have I done? No. Chat, cool. Let's all be cool now. 5 sine 45 over sine 5. Yeah. Right. Now, I won't type this in my calculator just yet because sine 45 is sine 5 is a small number, and I don't want to make any decimal errors yet. I'm going to leave it like this for more accuracy until the end, okay? I know x now, right? If I know x and I know an angle and I want the opposite and x is the hypotenuse, what should I use on this right angle triangle? Yeah, what is it?
Sine.
Sine. What's sine 50?
H.
H over x. Now what do I want? Yeah, so h is just x times sine 50, right? There's the x there. So therefore, x equals 5 sine 45 sine 50 all over sine 5. Now I can get it exact. I don't. What answer did you get here? How about you? Except you. Did someone else type this in? No?
31.
Yeah. So that's wrong at the back. So it's 31. Right, unless I typed something wrong here. Did anyone else get this? 31?
Yeah, that's one.
Alright, that's one tall tree. Okay, write this one down. Thank you.
Still, I don't understand how you got x equals 5 sine 45 over sine 5.
Here
Yeah.
comes from this one. And this one here is the sine rule. So I just rearrange this to get the x. So I bring the x up, bring the 5 up, bring the sine 5 down.
Why did you put 5? Not, can you go up?
Yep.
Okay. Sine 5. Why didn't you put sine 40?
Ah, I'm using the triangle on the left.
Okay.
So it's sine 5 over 5 equals sine 45 over x. Yeah? Is that okay? Yes?
Why did you get that?
Ah, why did I? Well, ultimately I want this height here, right?
Why didn't you calculate?
Why did I get the x?
Why didn't you?
Oh, why didn't I here? Ah, because I was worried that a small rounding error here would carry down too much to the next step. I mean, it's perfectly fine if you wanted to. I just wanted to be a bit more accurate, that's all. But if you prefer, what was the x? 40.57? Alright. That's fine too. Okay, will we go to the next one? Yep, alright. Right, so here's the diagram here. Dude's up the top of the cliff. He looks down at an island. And the two angles are 40. And then the other angle here for the end of the island is 30. Right, so what's the angle in between them going to be? 10. So maybe I'll just write it like that. So here has to be 30, and then this one here, 10. Okay. Now, what are we looking for? We want the height. Oh, and do you know how big the island is? Yeah, the island is 1 kilometre. The small island. Maybe it's one of these man-made islands. Maybe there's a hotel in the centre of it or something. The Arab students know what I'm talking about. Right. So this one looks a lot like the last one with the tree. It really is the same thing. First thing, what should we do? Let's get all the angles, okay? So, probably, maybe not cause confusion. I'll draw my cliff like this. No need to draw the man. Right. So, okay. Now, this angle here I can find. What's this angle? 80? No. 50.
Why?
Because the total here has to be 90. And if I make the cliff perpendicular, which I can, then this is 90. And then what's this one here? 40. So what's this one here?
140.
140. 140 and 10? 150. So here? 30. Now, doesn't that look familiar? Well, better. It's exactly the same as this one, instead of just turned around. See? You got a distance and all the angles. So what do you think I should find first? Well, this one here in the middle. So we'll use the sine rule. Sine 10 over 1 equals sine 30 over x. Therefore, x equals, I'll put it in as a decimal this time, sine 30 divided by sine 10. Right, so I need someone else just to double check it. What's the x here? 879, yep. Now that I have the x, I look at this right angle triangle, and what can I say on that triangle? Sine 40, what will that equal? H over x. So therefore, h equals sine 40 times x. Yeah, way off. 1.85. Well, someone else double check that on the calculator, please. Yeah, 1.85? Right, cool. Yes?
Why did you put the angle 30 and 40 there? Why? She said the question was with respect to the horizontal. So
Yeah.
you should put it down.
Yes. Sorry, with respect to the horizontal, really just means with respect to the x-axis, rather than with the ground.
How can you determine which location you should?
Well, in this case here, I put the angle up the top because it says that he's standing at the top. And he looks down at the start of the question. So he's here, at the top of the cliff, looking down. Yes? Yes?
How do you know that the angle there is 90?
Which one?
No, the angle there.
Oh, here?
Yeah.
Well, you can assume that the cliff is perpendicular with the ground. That the cliff isn't doing something weird like being at an angle.
The cliff usually is not vertical.
All right, okay. Fair enough, Hassan. I'll change it to say a vertical cliff. Just for you. No, that's true. You're right. Cliffs aren't usually vertical. So I should write in vertical cliff. Cliffs usually have a bit of a slant to them.
But you think
Yeah.
the height and the slant
Yeah, we're going to forget about slant and just go vertical. Or maybe I'll just say a wall, I think. Top of the wall. Don't worry, in the exam, they give you the diagram.
Oh, okay.
Always.
Yeah, so chill. It's all right. Okay. Did you write this down, or do you need a minute? You got it? All right, so number 5 now. Ship A. Oh, well, I'll call this one Ship B. Ship A is 40 kilometers east of B and 30 kilometers north. So it's 40 kilometers east and 30 kilometers north. Ship A is not moving. So this one is stationary, not moving. Ship B is heading northeast. So ship B is going this way, northeast. And because it's northeast, you know this angle. What angle is northeast? 45. You all know your compass, right? And then northeast, northwest, southwest, southeast. Yep, half a 90. Okay. What is the closest ship B gets to A? So ship B starts here, and then it moves along, and it's at its closest to A right here, when this distance perpendicular. So I want to find this length here. Yes? Now again, I want to try and just use my sine cosine rule. Now this isn't a triangle, okay, because this isn't straight here. It's bent a bit, okay? If you want to make it a triangle, you would have to do something like draw a line from B to A. Okay, now let me just erase this 45 to make some space. I want you to take out your calculator and tell me what this angle here is. Come on, tell me what this angle here is. You have the two sides. You have 30 and 40. So give me this angle. 36.9 degrees. So because you know the total is 45, give me this angle. 8.1. Now this is 90. Oh guys, come on. Tan, this angle is 30 over 40. So tan inverse 30 over 40 is that angle. No, don't look confused. Do you know where I got 36.9 from?
I did that.
I don't.
I'm not getting.
Joseph, are you confident with your angle there? Yeah?
Oh, 36.1.
Yes. Yes?
Yes.
Now, because the total is 45, then you know that this angle here is 8.1. This is 8.1 and this is 90, so you can get this angle. I got 81.9. Is that right? .9 degrees. Now, last one, I haven't gotten this angle in case I need it. So that angle there is 53.1. Now, I know it's a bit small here, but the key thing is we have all the angles here. Well, how did I get which one? How did I get which one?
53.
Because the total here has to be 180.
Oh.
Yes? So I have all the angles now. Also, this is right angle, so I can use Pythagoras, yes? So if this is 30, this is 40, who can tell me with Pythagoras what the hypotenuse is? 50. The hypotenuse here is 50. Okay, now we're finished nearly. So on the triangle on the top, I have all the angles and the hypotenuse. and I would like the opposite. So what should I use? Sine. So I can say sine 8.1 equals x over 50. So if I round it off, okay. I don't know. It seems like all my answers are wrong. Right, x is 7.05. What? Yeah, oh yes, thanks. Okay, I need you to write that down. It gets more difficult now in B part. Can I go on to B part? Yes? Okay. Now I don't... Hey, listen. I don't want to add extra information to this. It's getting a bit crowded. So I'll just roughly draw this again in the B part. So what happens in the B part, there's ship A, and then B is going by like this. We know this distance now. What is it? It's 7.05. And the question now is, ship B and A, oh wait, that should say ship B can call ship A if they are 40 kilometers or less apart. Ship B, yes? Oh, sorry. They don't want this distance. What distance do they want? Alright, so again, just use Pythagoras to give me this side here. I'll call it L. So using Pythagoras, you have these two sides here. What's L? Get calculating. $49.5. Oh, that is the answer at the back. Okay, 49.5. Thanks, Joseph.
Which sense did you use?
I used Pythagoras. This is the hypotenuse. So I said square root 50 squared minus 7.05 squared. And you got 49.5. Okay. Right, so, well, actually, yeah, but it doesn't change anything in the B part. You all got 49.5? No? You're off a little bit. Did you type in 7.05? No, minus.
Why is the minus?
Because the formula is L squared plus x squared equals 50 squared. And you want the L, so this comes over as a minus.
But he wants x in this question, yeah?
No, I misread it. He wants the L, but I got the x first anyways. He wants to know, if you look at there, how far has ship B traveled? That's the L. Okay. Yes, ready for the B part? Now in the B part, it says that they can radio each other when they're 40 kilometers or less apart. So what's going to happen is B is going to be heading along here, and then at some point, it's going to be 40 kilometers away. And then it's going to continue on its journey, and then later it's... What's wrong? No, listen. As I was saying, B is heading along here, everything's great. Then 40 kilometers away from A, it can radio, and it can continue to radio until, again, it's 40 kilometers away. And then once it passes here, it's no longer in radio range. Okay, and my question is, how far has ship B traveled while they are in radial range. So I want to know what this distance here is. Okay. Now what do we know? We know two sides, right? And I want this side here, I'll call it A. Now if I had this angle here, I would be done. What rule would I need to use if I had this angle here? Cosine. Now if I go back to the last one, what angles do I have? Well, I have 81.9, so does that help me? No. Okay, so let's work out the angle. I know this side here is 7.05. I know this side here is 40, so I can find this angle here. This is the what's it called? Adjacent, and this is the hypotenuse. So what do I use? No. Cosine. Thank you, Hassan. Cosine. Let me call this angle x. Cos x equals 7.05 over 40. So someone tell me what the x is. What's the x? 79.85. Okay. Now if you look at this triangle is exactly the same as this one, because the adjacent is still 7.05 and the hypotenuse is still 40. So that means this angle here is the same. So then what's the total angle here? No, it's not a trick question. What's the total angle here? What would it be?
159.
Yes, how did you get that? Yeah, just multiply this by 2. So the total angle would be 159.7, we'll say, yeah. Now, we have side, and angle. So now I can use which rule? Cosine rule. A squared equals 40 squared plus 40 squared minus twice 40 times 40 times cos 159.7. Okay, tell me what you got for A. What did you get for A?
78.
Yeah, about 78.74, something about this, yeah? Yep.
Well, you should have just found used Pythagoras for one side, then you multiply the answer by 2 to get the.
Use Pythagoras to get this side.
Yeah, then it's the same with the other side. So
Yeah, you could do it this way. But I wanted to use my cosine and sine rule. There's many ways to do these. Look back here. Do you see this example here with the tree? This is only one way to do it. There's other ways to do it by using things like tan. The only reason I'm doing these this way is because I need you to practice using the sine and cosine rule.
What was the answer?
78.74. Okay, 0.75, yes, thank you. Okay, I'll let you write this down. There's still a C part to do now. Will I do it now, C part? Yes? Okay. So, in this situation, ship B is not allowed to be any closer than 2.73. So ship B sets off at some angle, or that's totally wrong. There's A up there. Ship B sets off at some angle so that This distance here is now 2.73. And my question is, what's this angle that makes it have this distance of 2.73? Now, this distance here is still, what did I say it was? 40. And this distance here is still 30. And I can still say this angle here is, what was it? 36.9. So really, I'm trying to figure out what angle do I need to put here to make this triangle. Okay? Well, I still know that this here is 50. I still know that this is right angles. I'll call this x. So what can I use here? I have opposite and hypotenuse.
So sine.
Sine. So sine x equals opposite over hypotenuse. So what's the x, please? .13.
Yeah.
Now, of course, that's not the final answer. The final answer is the whole angle here. So the angle equals that plus 36.9. So 40, basically. 40 degrees. So originally at the start the ship sets off at 45 degrees, and what is the closest it gets? At 45 it was 7.05. And then what happens is the ship lowers its angle to 40, and now it's 2.73. What angle would the ship B have to set sail at so that it impacts A? 36.9. Okay, that's number 5 done, so you can write that down. I don't think these are as difficult as you think. I think the problem is using your imagination.
Yeah.
Too much video games destroys your imagination. Can't picture anything anymore. Yes? Okay, number 6 now. Is number 6 now? Yes, okay. 6. Right, Arab students, do you know this dude here? Look at number 6. No, really? Have you heard of him before?
I have heard the name before.
Anyways, this is the guy who estimated, from science, estimated how big the Earth is. And the diagram is how he estimated. So what happens here is he wants to estimate the radius of the Earth, and he suggests going to the top of a mountain of known height h. Then you are to look at the horizon, so you're looking down at angle alpha. And this is actually enough information to work out how big the Earth is. So,
I thought it was someone else who discovered how.
well, there's a couple of people, but he was one of them. Yeah. Right, so let's look here. So we have our Earth, and we want to estimate its radius. Now, we climb up a mountain of some height h that we know. How could you work out the height of a mountain? Well, that's actually, remember earlier I did the question with the tree. Yeah? So, yeah, in that question here with the tree, if I go back here, all she needed was 3 pieces of information to get the height of the tree. First, she stands and looks at the top of the tree, right, and measures the angle. And then she travels a fixed distance, like 5 meters, which she can measure on the ground. And then she looks up and gets a new angle. So she has angle, and distance she walked. This was enough to get the height of the tree. You can do the same thing here to get the height of the mountain. So anyways, we're just going to call the mountain height h. But you might ask, well, how can you work out the height of a mountain? It's the same way we did the height of the tree. Okay, so the height is known. Then, once you're at the top of the mountain, you look down to the horizon. You know horizon? Off in the distance? Yes? No? Do you know what I mean when I say horizon?
Yeah.
Under the sea.
Yeah, that where like the top of the sea, where the sun sets, the horizon. So you look down, so that would look like this. Well, it's in the diagram there. Okay. This here is or. This here is or. This here is 90, and this angle here is alpha, and that there is height h. And we want to calculate the or here. Okay, that's alpha there. Now, just to make it a little bit easier for me, I'll call this angle here beta. But who can tell me what beta equals? What's beta? Come on. If the whole angle here is 90, try again,
90
Avenue.
minus alpha.
Thank you. 90 minus alpha. That's this angle here, yeah? Now, let's call this angle here gamma. How do I get gamma? 180 minus 90 minus...
So just 90 minus beta.
No, don't ruin the surprise. 90 minus beta. It's 180 minus these two, yes? Okay, what's 180 minus 90? 90. And what's beta? So they cancel and you get here alpha. So this angle here is also alpha. Okay. Now, let's see. If I draw this triangle down here, we know this angle is alpha. The two things we know are alpha and h. Okay? We know alpha. How big is this side here? Now use your imagination. Flip this down here. Come on. This one here. Well, this one here we don't know. Sorry, I should have been saying this one here. How big is this hypotenuse here? H plus R. And how big is this piece here? R. Now, we have hypotenuse and we have adjacent. So what could I use here? No, stop saying Pythagoras. What do I use? Cos. So cos alpha equals R over H plus R. Now, let's not forget here, what am I looking for? H. So I need to rearrange this. So I have H plus R times cos alpha equals R. So I get H cos alpha plus R cos alpha equals R. So H cos alpha equals R minus R cos alpha equals R times 1 minus cos alpha, H cos alpha. And then finally, R equals, what will be? H cos alpha all over, come on, 1 minus cos alpha. So, climb up the mountain of height h, look down to horizon, measure your angle that you look down at, and put it into this formula, and you've got the radius of the Earth. Come on, that's at least a little bit cool, right? No? All right. I should say, okay. Okay, write this one down now. Okay. Do you have this taken down now? Oh. By the way, this is exactly how it was done, whatever year this was. I don't think I said what year it was. Do you know, Sarah, what year this guy was? No? A while ago, anyways. This is exactly how it was done, okay? He went up the nearest mountain of known height and looked down and put his result into that formula. And I think the result has less than a 1% error. Okay, so it's, pretty good. Okay.